So today we're going to be graphing rational functions. So when I refer to a rational function, I'm talking about fractions. So we've already learned how to solve rational functions. Now we're going to graph them. So by definition, a function that is in this form, where p of x and q of x are just some kind of polynomials. So for example, the function could look something like this. It could be f of x is equal to 2x plus 1 over x squared minus 4. And we're going to be graphing this thing. Okay, and we're going to learn how to find the asymptotes, how to find the x-intercept, the y-intercept, and then additional points. Now, you should already remember how to find x and y-intercepts. You just plug in the zeros. To find the y-intercept, you set x equal to 0. To find an x-intercept, set y equal to 0. But as far as the asymptotes, we're going to follow some steps here. We can pretend like that's not there. Is that what you're talking about up here by the q of x? By the q of x, you mean? Oh, yeah. Forget that that's there. It's just a comma. All right, so here's an example of a rational function. This is actually the reciprocal function. This is like the simplest fraction we could set up here. And if I ask you to graph this, remember the domain is always starting out as all real numbers, except when the denominator, whatever would make the denominator 0, that's what we would exclude from our domain. So here, what x can't be is going to be 0. So if you think about this, my domain is going to be all real numbers except for the 0. So it goes from negative infinity, jumps over the 0, and then goes to infinity. So that's why they wrote the domain this way. Now, in actuality, we actually have a vertical asymptote at x equals 0. The way that you find a vertical asymptote is we take the denominator, whatever's in the denominator, and set it equal to 0. We solve for x, and that gives us our vertical asymptote. It's going to be an equation, x equals. For the horizontal asymptote, we need to look at the degree of our polynomials. And then there's going to be 3 different scenarios. And the 3 scenarios are going to be when the degrees are the same, top and bottom, when the degree of the top is bigger than the bottom, and when the degree of the top is smaller than the bottom. And 3 different scenarios are going to happen. I'm going to show you that in a minute. So let's go ahead and let's say they ask you to graph this and you had no clue of how to make a graph for this. So what you could do is you could make your own little table of values here and plug in numbers for x. Now this is actually going to have 2 portions because this graph actually has a horizontal asymptote, which is the x-axis, and it's got a vertical asymptote, which is the y-axis. So when I go to graph this, if I plug in numbers, let's say I plug in 1, 2, and 3, if I take my equation, which is this, my function is f of x equals 1 over x. So if I take 1 and I plug it in for x, I get 1, so I'd graph the order pair 1, 1. Then if I put 1 over 2, then I graph the order pair 2 1/2. And then 3, and that would be 3 1/3, and so on. Now, I could also plug in negative numbers. Oh, let me do it over here. Negative 1, negative 2, 0, negative 3. So here, when I put in negative 1, I get negative 1. Over here, I would get negative 1/2, negative 1/3. So now when I go to graph these, my order pair 1, 1 is here. Then this one, 2, 1/2. And then here, notice my graph is going to look like this. Notice that this asymptote here, my graph is approaching it, but never touching it. And then I've got the vertical asymptote, and notice how my graph is skimming along. Over here, if I graph these order pairs, I would get negative 1, negative 1, then negative 2, negative 1/2, and so on. And it would go like this. So what we would do is, instead of having to make tables like these to get our ordered pairs, we would key the y equals button, and then we would put 1 divided by x, and then hit second graph and get ordered pairs to make your graph. So let's first figure out how we can figure out where we have a vertical asymptote and where we have a horizontal asymptote. So for finding the vertical asymptote, you just take the denominator and you set it equal to 0 and solve for x. The number you get is your vertical asymptote. Now, as far as the horizontal asymptotes, we have 3 different scenarios. And this is when we're going to look at the degree of our polynomials. If you recall, the degree of your polynomial is the largest exponent. So for example, on this one, the first one, this is if the numerator has a lower degree than the denominator. So for example, let's say you have x plus 1 over x squared plus 1. Notice the degree of my numerator is a 1, and my degree of my denominator is a 2. So because the numerator has the lower degree, my horizontal asymptote occurs at the equation y equals 0. When the numerator and the denominator have the same degree, let's say it's 2x plus 1 over x plus 3. Notice they both have a degree of 1. So for this horizontal asymptote, I use the coefficients of my leading term. My leading coefficients are 2 over 1. So my equation is going to be the line y equals 2. When the degree of the numerator is 1 more than the denominator, so let's say it's x squared plus 1 over x plus 3. In this case, I do not have a horizontal asymptote. I'm going to have a slant asymptote. And the way that we find the equation of that slant asymptote is I do a long division problem. So what we learned at the beginning of the chapter is coming back. And now I would do long division using this to get my equation for my slant asymptote. So again, what am I going to multiply x by to make it x squared? I'm going to multiply it by x. So x times x gives me x squared. X times the 3 gives me 3x. Yes? You can't. You have to do long division. So then now I flip the signs. So then I get negative 3x. Drop down the 1. What am I going to multiply x by to make it negative 3x? Negative 3. So negative 3x minus 9. Flip the signs. I don't need this remainder. All I need is this. So my slant asymptote occurs at y equals x minus 3. No horizontal this time, just a slant. And then I would graph this line using y equals mx plus b. So let's go ahead and let's see some examples now. We'll put it all together. Now, the next slide, this is telling you how to find the vertical asymptote. Again, set the bottom or the denominator equal to 0. You're going to get x equals, and that will give you your vertical asymptote. The vertical asymptote is a vertical line that your graph will approach, but it will never cross. The horizontal asymptote is a horizontal line that as your graph approaches infinity, most of the time the graph will approach it, never cross it. There will be the occasional time that it will cross it, okay? But it will never cross a vertical asymptote. So again, this is a typo here. This should be equal here. So when the degrees are equal, that's when you take the coefficients and make your equation. When the degree of the numerator is the smaller one, it's automatically y equals 0. When the degree of the numerator is bigger, that's when you do the long division. And that will give you the slant asymptote. So again, here is the same thing again, but with examples. So again, this is when the degrees are equal. This is where we're going to take the coefficients, and my horizontal asymptote occurs at 1/3. This is where the degree of the numerator is the smaller one. So then this is automatically y equals 0. It's the x-axis. And then when the numerator is the larger degree, this is where I do the long division. It doesn't have a horizontal. It has a slant. So I'm going to do x plus 1. And then in here, remember to hold the place with a 0. And now divide it. X times x is x squared plus 1x. Flip the signs to opposite. Negative 1x plus 3. Multiply. And then flip. So my slant asymptote is y equals x minus 1. So that's how the 3 scenarios. So when you're looking for your horizontal, you're going to have one of these 3 cases happening. So let's try this. I'm going to do a bunch of examples. Here's the first one. Oh, these are the steps we're going to take. So the first thing we're going to do is find the vertical asymptote. Then we're going to find the horizontal or the slant. Here they're calling the slant asymptote the oblique asymptote, but also know it can be referred to as the slant asymptote. Then we're going to find the y-intercept by setting x equal to 0. Then we're going to find the x-intercepts by setting y equal to 0. And then from there, we're going to graph the asymptotes. And then we're going to graph some more points. And we're going to get those additional points from our calculator. So let's try it. So again, step number 1, find the vertical asymptote. And I'm going to do the vertical in blue. So for the vertical asymptote, you set the denominator equal to 0. So x minus 4 equals 0. I'm going to solve for x. And I have a vertical asymptote at x equals 4. For the horizontal asymptote, this is where I look at the degrees. Notice the degrees here are equal. So this is where I use the coefficients. So I'm assuming a 1 in front of this x and a 1 in front of this x. So my horizontal asymptote occurs at 1/1 or at y equals 1. I'm going to graph this horizontal and this vertical line. So the vertical I'm going to graph in blue. So 1, 2, 3, 4. I have my vertical asymptote at x equals 4. And I have my horizontal asymptote at y equals 1. I'm now going to find my y-intercept. That's my next step. Remember to find the y-intercept. You set x equal to 0. So y equals 0 plus 1 over 0 minus 4. Y equals 1 over negative 4. So my ordered pair for my y-intercept is 0, comma, negative 1/4. I'll graph this in green. So So I'll say it's right about here. Next, I'm going to find my x-intercept. And again, set now y equal to 0. 0 equals x plus 1 over x minus 4. I want to get rid of the fraction, so I'm going to multiply both sides by x minus 4. This cancels. 0 times anything is 0. And now I solve for x. Subtract 1. X equals negative 1. So my x-intercept will occur at -1, 0. I'll go ahead and put my point right here on -1. Pretty good so far? Now, what we need to do is figure out order pairs for my graph. So let me go ahead, I'm going to key it on my calculator. I'm going to take a picture of my calculator or hold the camera over it, and then I'm going to do it on the board too. So everybody go ahead, if you have your calculator, I want you to key this equation in your calculator. Now, if you do not enter it as a fraction, what we need to enter, we're going to hit the y equals button. Then when we go to enter it, we need to use parentheses. So we're going to do open parentheses, x plus 1, close the parentheses, divided by x minus 4. And these two expressions are in parentheses. If you do not put them in parentheses, it will not give you the same answer. Okay, so key that in your calculator. You can hit graph, and we can also get some ordered pairs. So let me go ahead and key this in. Question. So when you're looking at your table, if you see the word error, then you know that that's where your asymptote is. And you're not going to have any points there. And you'll see the word error. So let me go ahead and I'm going to write down some ordered pairs that I'm going to graph. So I'm going to look for some ordered pairs over here, -2, -3, -4. So for -2, now it's approaching, my x-axis. So at -2, the ordered pair is 0.166 repeating. So this is kind of hard to graph. It's going to be really close to the x-axis. If I were to graph the ordered pair, I already have -1. Let's say I did -4 just to get another point here. So -4 is going to give me 0.375. So if I graph these, what you're going to see is you're going to have points here, like really close, and then -4 gets a little bit out. So far, it's coming down, and then now I'm going to look at the point for 1, and 1 is also a decimal. It's 2/3, -2/3, or 0.6 repeating. And then 4 is the error. 5, that's going to be on the other side. So let me just do 3. 3 is at -4. So 1, 2, 3, 2, 3, 4. So then it's coming and it's approaching this way. And notice how it's skimming along that red highlighted horizontal asymptote and the blue vertical asymptote. Now, I need to find the points 5, 6, 7 to finish the graph. So if I look at my calculator, the ordered pair for 5 is going to be 5, 6. If I go ahead and pick another one bigger than that, 6 would be at 3.5. 9 is going to be at 2. So just graph these ordered pairs now. So this is 5, and I need to go up to 6. So 2, 3, 4, 5, 6. Then when I graph 6, 3.5. So 6, and then 1, 2, 3.5. And then if I went out to 9, 6, 7, 8, 9, and then it's coming down this way. So I would get at least 2 points on, so you can see like that boomerang shape that it's taking on. And again, use the asymptotes as your guide. Okay, let's try the next one. Again, step number 1 is to find the vertical asymptote. Remember, to find the vertical asymptote, you take the denominator and set it equal to 0. So we'll subtract 3, x equals negative 3, and that will give me my vertical. I could go ahead and graph it now. So if I come over here, 1, 2, 3, my vertical asymptote is the vertical line through x equals negative 3. To find the horizontal asymptote, we're going to look at the degrees. This time, the degrees are the same. So again, 1 over 1, so y equals 1. So same scenario as last time. So again, here would be my horizontal. I'm now going to calculate my y-intercept and my x-intercept. Now, technically, you can get this from your calculator. Remember, for the y-intercept, you're looking to see when x equals 0. For the y-intercept, you're looking to see where x, for the y-intercept, where x equals 0. But let's do it by hand. So for the y-intercept, I set x equal to 0. So y equals 0 minus 5 over 0 plus 3. So y equals negative 5 over 3. So my y-intercept is 0, negative 5 over 3, which is like negative 1 2/3. So I could go ahead and graph that. So I could put my point right here. Let me do it in green again. So that's my y-intercept. To find my x-intercept, set y equal to 0. So 0 equals x minus 5 over x plus 3. Now remember, whenever we're doing this, essentially to find this x-intercept, all I'm going to do is set the numerator equal to 0. Bottom line here. Because remember, we're trying to get rid of the denominator. So I multiply both sides by the x plus 3. 0 times anything is 0. So again, that's all I'm doing here. Is x equals 5. So the x-intercept is at 5, 0. 1, 2, 3, 4, 5. And the x-intercept would be right there. And now I need to get additional points. And I would key it in my calculator. Again, remember, you're going to do x minus 5 in parentheses divided by x plus 3 in parentheses. So again, hit the y equals button. Remember to put them in parentheses. I have an x-intercept here at 5, 0. So the red part of the graph down here does cross the x-axis. And then here's the black part up here for the values that are less than that vertical asymptote, which remember was at x equals negative 3.
So how do you get the red line? You just go to the table of the graph, right?
Same thing. You do the same thing for the black line. You're just looking at order pairs that are starting at negative 4, negative 5, negative 6. So then I just looked at my table and I got these order pairs. Negative 4, 9, negative 5, 5. Does that make sense?
Yes.
So again, all the order pairs are coming from your table. But first, let's do the vertical. Now, I shouldn't have shown you this. So whenever you have a polynomial or a trinomial that can be factored, in order to find the vertical asymptote, we need to factor that polynomial. So I'm going to factor x squared plus 6x plus 8. Factors of 8 that give me 6 are going to be 2 and 4. To find the vertical asymptote, there's going to be 2 of them. Yes?
What if it can't be calculated?
It will be for us. Otherwise, If it can't be, then you would do quadratic formula and you would get radical asymptotes. All right, so here, x plus 2, this is the work for the vertical asymptote. X plus 2 equals 0, x plus 4 equals 0. Negative 2, negative 4. So I've got two vertical asymptotes. So let me draw them in blue. 1, 2, 3, 4. So I've got one here at negative 2 and one at negative 4. Now I have to find the horizontal asymptote. So for the horizontal asymptote, this is where we're going to look at the degrees. The top degree is smaller. So this tells me it's automatically y equals 0. So when the top degree is smaller, it's y equals 0. Remember, when the top degree is bigger, we do long division. So my horizontal asymptote is the x-axis. So now what I need to do is, well, first I have to find my intercepts. But essentially what you're doing in order to get your graph is you're going to look at your table and you're going to start looking at all these x values to figure out negative 1, negative 3, negative 5, negative 6. Figure out these order pairs so you know what your graph looks like. So let's go ahead and first find the y-intercept. Set x equal to 0. So 2 times 0 plus 1 over 0 plus 2 and 0 plus 4.
Where'd you get 1 and 2 from?
So then here I now get 0 plus 1 is 1, and then 2 times 4, and I get 1/8. So my y-intercept occurs at 0, comma 1/8. My x-intercept, I'm going to set y equal to 0. And then I'm going to solve for x. So again, I want to get rid of the fraction. So multiply both sides by x plus 2, x plus 4, cancels. And I get 0 equals 2x plus 1 minus 1 divide by 2. So my x-intercept occurs at negative half, comma 0. So my x-intercept will be here, and my y-intercept is going to be like at this 1/8. Okay, so now let's go ahead and key this in our calculator to get some more order pairs. So I'm going to key in the original problem. Don't key in the factored one. So key this in, parenthesis around this with a division. So parentheses 2x plus 1 divided by parentheses x squared plus 6x plus 8. Close parentheses. All right. So I'm going to go ahead and look at my table here and get some order pairs. So for negative 6, that order pair is negative 1.375. Then if I get negative 5, that gives me negative 3. So I can start to graph these. So at negative 6 and negative 1.3, I could say it's about here. Then 1, 2, 3, and then negative 5 is here. So this piece of the graph, again, is going to skim these asymptotes. Then over here in this section, I'm going to look at the order pair negative 3.5. So I'm going to make my graph go by 0.5 so I can see the U shape forming. So at negative 3.5, I'm getting 8. At negative 3, I get 5. And negative 2.5, I get 5 1/3. So let me graph these. So negative 3, and then let me go up to 8 here. So 1, 2, 3, 4, 5, 6, 7, 8. So negative 3 and 8. Then negative 2.5 and 5. Let's see. All right, let me start over here. All right, so at negative 2.5, I have 5 1/3. So 1, 2, 3, 4, 5 1/3. Then at 3, I've got 5. And then at 2.5 or 3.5, I'm going back up to 8. So then you can see that it's taking on a U shape. And again, you can see that once you hit the graph button. And now I need to figure out some points over here. So let me figure out what negative 1 is. And negative 1, that order pair would be negative 1/3. Then if I plug in 1 or 2, so 1 would be 2/10. 2 would be 0.20. So again, you're going to start seeing that this is just skimming along the asymptote. This is the scenario where it crossed the horizontal asymptote, but now it's skimming along the other side. Generally, it stays confined, but this would be the scenario where it crosses that horizontal asymptote, and now as it approaches infinity, it's skimming along. And you can get these order pairs. Okay, so this example, this is the scenario where the degree of the numerator is larger. So let's try this one. Again, your vertical asymptote you find by setting the denominator equal to 0. So I get a vertical asymptote at x equals 4. And then for the horizontal, I look at the degrees. The top is bigger, so I need to do long division here. So because my degree in the numerator is bigger, the horizontal asymptote is none, but it does have a slant asymptote. So I'm going to go ahead and do the long division here. So I'm going to multiply x by 2x to get 2x squared. Flip the signs. This is gone. And now I'm going to multiply x by 8. I don't need the remainder, so I just throw that away. So my slant asymptote is going to occur at 2x plus 8. I'm now going to graph this slant asymptote. This is in y equals mx plus b form. I'm going to start at positive 8, and then I'm going to move my slope. I'm going to rise 2 and run 1. Let me go ahead and put that on my graph. So I could also put in my vertical asymptote. So 1, 2, 3, 4. My vertical asymptote is here. And then for my slant, 1, 2, 3, 4, 5, 6, 7, 8. I start at positive 8. It's my first point. From that point, I rise 2 and run 1. So my slant asymptote is the equation of that line, which is y equals 2x plus 8. I now need to find my x-intercept and my y-intercept by plugging in the zeros. So for the y-intercept, set x equal to 0. So 2 times 0 squared plus 3 over 0 minus 4. So I get 3 over negative 4. So my y-intercept is 0, negative 3/4. So let's say this is 1. So we'll say 3/4 is about here. And then for the x-intercept, your graph is going to look like this. It's going to be a little piece up here. Because let me extend my vertical. And then the other piece is down here. Okay, so for this question, we also need to find the x-intercept. So again, I'm going to take my equation. I'm going to set y equal to 0. And I get 0 equals 2x squared plus 3 over x minus 4. Get rid of the denominator, so multiply both sides by x minus 4. X minus 4 times 0 is just 0. This cancels. I'm going to move the 3 over. Negative 3 equals 2x squared. Divide by 2. Negative 3 over 2 equals x squared. Notice when I try to square root it, this is going to give me an imaginary number. So this has no x-intercepts. So let's go ahead and key it into our calculator and let's get some additional points. So I've already done a rough sketch here, but let me go ahead and put some markings here. So some additional points for this side. We could say that we have the order pair -2 and -1.833. And this is all from your calculator. So at -2 and then 1.8. I can move my graph down here a little. Go ahead and add that in, -2. And we'll say it's around 1.8. So it can go here. And again, we're going to use our asymptote as a guide. We could graph another order pair over here, 1 comma, -1.6 repeating. So 1 and then -1.6. And as you can see, your graph is going to come around looking like that. I also need to figure out some points up here. So this would be, I could look at x equals 5 on my calculator. And that order pair would be 5 comma 53. I could look at 6, and that would be the order pair 37.5. So 5 and 6. So at 5, we could say this is 5 comma 53. And then here at the 6, it's coming down, and that could be the 6 comma 37.5. So again, all of these points are coming from your calculator. Once your function is keyed in, then you can hit second and graph, and you can get order pairs from the table. Okay, we have one more example. So notice for this one, I'm going to go ahead and factor the numerator, and that'll become x plus 3, x minus 3 over x plus 3. Now, for this one's a little different. Notice after I factor this, I can actually cancel the x plus 3's. So this tells me that when I can cancel something, the same thing from the numerator and the denominator, when I set this equal to 0 and solve, at this value, at x equals -3, I'm going to have a hole in my graph. Now, to figure out exactly where the order pair is, I'll take what remains, the y equals x minus 3, plug in -3 for x, And the order pair where the hole will occur is -3, -6. Now, for this one, there is no vertical asymptote. The denominator is gone. We just have a hole. And then for the horizontal asymptote, remember when we check the degree, this time the numerator is greater than the denominator's degree. So this tells me that there is no horizontal asymptote, but we do have the slant asymptote, which is just our equation here. So let's go ahead, and whenever you're looking at your calculator, the chart or the table is going to show an error wherever there is the hole in the graph. So I'm going to go ahead and graph y equals x minus 3. I'm going to start at my y-intercept, which is -3. Put my first point there. My slope is 1, so I'm going to rise 1 and run 1 from this y-intercept. So up 1 and over 1. You could keep repeating the pattern if you wish. However, remember about our hole over here. So when x equals -3 and 4, 5, 6, -6, this is where the hole will occur. So the graph of the line will be from here to here, excluding this order pair, which is -3, -6. This is where the hole will occur. So again, the domain restriction is something we need to check out. So this is the graph of this rational function. And again, remember, if you can cancel something, the exact same thing from the numerator and the denominator, that is where you will have a hole in your graph. So your homework due on Wednesday is page 365, numbers 53 through 65 odd.